So till now we have learned HCF and about the real life applications about the HCF and LCM. And for HCF we need to it's basically concern associated with the divisibility, and the LCM is associated with the multiples, that means multiplication. So for both that we need to learn tables. So if child knows 2 to 12 tables, then well and good. Or if the child can do up to 18, 19 table, it will be more easier for the child to understand and grasp the, and it will just speed up the process of dividing and multiplication. Okay, so if it doesn't happen, so that also okay. We know we are going through the divisibility rules. At least 2 to 11 they get to know how it is to be done. So we have if any number given to find out HCF or LCM about the number. So they can give 2 digits number or 3 digits number. So 2 digits number, if we have 24, 12, 16, 18. So these numbers are very small numbers, and we remember these numbers that this comes in 2 table or 3 table. But what if there is a number which are bigger? So in that case, how will we find out whether this number, which table is going to applicable on this number? So for example, we have 920, so and so. Once on, you have to remember here for finding out whether this number is divisible by 2 or not, we will see whether on its ones place, that means its units place, whether there is any even number 0, 2, 4, 6, 8. So if it has any even number on the ones place, that means this place is, sorry, this number is divisible by 2. Next, if a number that is for smaller numbers, 9, 6, 9, 12, 18, 15, 21. If you know these numbers, that these are the divisible by 3, then you don't have to calculate much. But what if bigger numbers are given? So in that case, what you will do, you will split all these numbers and make a sum out of it. So 5742 is given, and if you are adding all these numbers, you will get 18. So 18 is divisible by 3. That means this big number, you can divide it by 3. And if you see it has even number also, so it can also be divided by 2. So both by 2 or 3 you can apply on this number. Next is next is if this number is divisible by 4. So what you have to see, the last 2 places of the number, okay, last 2 digits, ones place and tens place. So 16, it comes in 4 table. If this happens, like last 2 digits are divisible by 4, then this number can be divided by 4. And here 48, here 0, 8. So 8 is there, but what about 0? You can see if you wanted to check. 4 5s are 20, 3 comes here, 4 7s are 28, 2 gets carried forward to over here, and 4 7s are 28. So it is divisible by 4. If you want, you can simply divide it on your notebook right now so that you can find out. 196, again 4 2s are 8 and 1 carry forward. So 4 4s are 16. So it happens. That means this is happening. This also divisible by 4. So all these numbers has last 2 digits which are divisible by 4. So these numbers can be divided. Next, if any number that ends with 5 or 0 is divisible by 5. And what about 6? For 6, we have directly we don't have any rule about 6. One moment. So directly we don't have any rule. Sorry, I'm so sorry. Please excuse. Directly, we don't have any such rule, but yes, we are splitting into ways. If any number is divided by 2 and as well as 3 also, in that case, that number can be divided by 6. Suppose we have 630. So the last digit is 0. It is definitely going to divide it by 2. But if addition 6 plus 3 is 9 plus 0, 9. So it is divisible by 3. So you have to make out like that. Whether this number can be divided by both 2 and 3, then only then it can be divisible by 6 also. For 7, we have a little bit trick. Double the last digit of the number. That means if any number is given here, 1463, so last digit means ones place. So 3 plus 3 is 6. And then subtract it from the remaining number. That means you have to subtract this 6 number from 146. So 146 minus 6 is equals to 140. And 140 is divided by 7. Yes, it is applicable. Answer is 20. So this whole number is can be divided by 7. Number 8. The last 3 digits are divisible by 8. You have to see whether the last 3 digits are divisible by 8 or not. So 8 8 fives are 40. Then 5 comes out of it. 5 gets carried over. 8 sevens are 56. Yes, it can be divisible by 8. Same way. Last 3 36 numbers, see, 8 fours are 32 and 1 carry forward. 8 twos are 16. So that means it is divisible by 8. Next is the sum of digits of the number should be divisible by 9. So if you get any big numbers, small numbers are okay because you know the tables. But if there are big numbers, what you will do, you will add all these numbers and that numbers add up to the number that is divisible by 9. Then it is the number that can be divided by 9. So 18 and 27 we got by adding all these digits, and we get to know that this number is divided by 9. Any number that ends with 0 is 10, divisible by 10. So that is very easy, everyone knows. 11. If the difference of sum of alternate places. Now here we have alternate places. Alternate means, for example, 2, then skip 1 and then 4. So 2 and 4 adds up to 6 and 1 and 3 adds up to 4. Now this 6 minus 4 is not divisible. Why? Because it gives 2. So 2 doesn't come in 11 table. Next, 9 plus 7 is 16 and 3 plus 2 is 5. 16 minus 5 is 11. So 11 is divisible by 11. So we have get to know all these divisibility rules. So next we have number of prime numbers. There is list of prime numbers between 1 to 1000, but you won't need at this moment in grade 5. Till 100 it is okay. You can take a screenshot or you can refer video anytime. 1 to 100, what are prime numbers? Prime numbers are the numbers that those doesn't come in any table. They are only divisible by itself and their cofactor is 1. So 2 ones are 2, 3 ones are 3, 5 ones are 5, 7 ones are 7, 11 ones are 11, 13 ones are 13, 17 ones are 17. It's like that. It will never come in any table, only in their table itself. Okay. Between 1 to 100, we have 25 prime numbers. And between 1 to 50, we have 15 prime numbers. And between 51 to 100 we have 10 prime numbers. The numbers that comes in other table, that means those are not prime numbers, right? And those which are not prime numbers is called as composite numbers. And there can be a question like tell us any six consecutive numbers, consecutive composite numbers. So there are six consecutive composite numbers that comes between 90 and 96, 90, 91, 92, 93, 94, 95, 96. So these are the numbers that comes uh, in, in the tables. Okay, those are not prime numbers. Those are the numbers which come back to back, and it doesn't have in between any prime number. So you can write down in the exam like that. So for the timing, it is okay if you get through this. The rest of the numbers you will get to learn as and when you promoted to higher grades. That's all for this video.